All right, today's lesson is on transformations of the exponential function. So this lesson is all on graphing. So if you look at both of these, we've been dealing with graphs that are like these yellow ones, and we're going to be shifting them left and right and up and down. All right, so instead of just a times b to the power of x, we are now looking at adding or subtracting in the exponent and adding or subtracting after. Okay, so starting with the value of a, in the previous lessons we've talked about that being the y-intercept. But the a also will either stretch or compress or reflect. So stretch, if the larger a is, the quicker it will increase. Compress, if you have a smaller number for a, it might increase a little bit slower. And then reflect, let's say this is our x-axis. Instead of increasing, it will be flipped over like that. And that is when, as you could probably guess, when a is negative. Okay, h, adding or subtracting in the exponent, that is going to create a horizontal shift. So let's say I have y equals 3 to the power of x minus 2. If it's in the exponent, then it's opposite of what you think. Minus 2, it's actually going to shift right. And if we had y equals 3 to the power of x plus 4, opposite, it will shift left. And you can probably guess what happens when you add or subtract at the end. That is your vertical shift, shifting up or down. So it's going to shift your asymptote. I'm going to write that down. It shifts the asymptote. So, and this is not the opposite. This is if you had y equals 2 to the power of x, and then after the exponent a minus 5, that is going to shift down. And y equals 2 to the power of x, and then a plus 2 after, that will shift up. All right, so our first graph is y equals 2 times 1/4 to the power of x minus 2. So let's see, if we're going to visualize this one, this will be shifting right because of the minus 2 in the exponent. And really what we're going to do is we're just going to make an xy table. But one thing that you can visualize is that y-intercept is no longer a. It's not going to be at 2, but it will shift to the right 2. So if I start with, let's say 0, so I have 2 times 1/4 to the power of 0 minus 2. So 0 minus 2 is negative 2, and then this will equal 32. So that's going to go off my graph. If I plug in 1, 2 times 1/4 to the power of 1 minus 2. So do your exponent. 1 minus 2 is negative 1. When you plug that in, you are going to get a positive 8. So we can graph that. All right, let's plug in 2. 2 times 1/4 to the power of 2 minus 2. This one's an easy one because 2 minus 2 is 0. 1/4 to the power of 0 is 1 times 2 is 2. Let's get one more. 3. 2 times 1/4 to the power of 3 minus 2. 3 minus 2 is 1. 1/4 to the power of 1 is 1/4 times 2 is 1/2. All right, so it's just making an XY table. The equations are just a little bit more complicated. So we can't plot that one, but let's plot 1, 8 and 2, 2. And then 3, 1/2. And let's see, it hasn't shifted up or down at all. So here's still the asymptote. Your graph will get really close to the x-axis, but never cross it, and then increases quickly. Notice how this is exponential decay because the b value is between 0 and 1. All right, and the last thing, domain and range. This actually is going to be similar to what we've been working on. The domain is all real numbers because it goes forever and ever in both x directions. But our range are only y values greater than 0. All right, so y equals 1/2 times 4 to the power of x. I'm not adding or subtracting anything in the exponent, but afterwards I'm going to do minus 5. So this is going to be a shift down, and what it does is it shifts the asymptote. So instead of the x-axis being the asymptote, it's going to be at -5. If I go down 5 and draw a horizontal we just do a dotted line for asymptotes. All right, so now let's make an XY table. I'm going to plug in, I'll start with 0. 1/2 times 4 to the power of 0 minus 5. 4 to the power of 0 is 1 times 1/2 is 1/2 minus 5 is -4.5. So if I plot that point 0, -4.5 will be here. If I plug in 1/2 times 4 to the power of 1 minus 5. 4 to the power of 1 is 4. Half of 4 is 2, and 2 minus 5 is -3. So write 1 down 3. If I plug in 2, 1/2 times 4 squared minus 5. So 4 squared is 16, half of 16 is 8, and 8 minus 5 is +3. So write 2 +3. And we can already see it, but also the b value should show that it's exponential growth, so it will get really close to this asymptote, and then zoom, increase. All right, so now let's look at domain and range of this one. The domain is still all real numbers because it's going forever and ever in both x directions, but now it is hitting all y values that are greater than what? -5. All right, so this one is a combined horizontal shift and vertical shift. I want you to try this one on your own, and then we're going to do one more together where there's a reflection. So pause the video, try this on your own, and come back and check. All right, so here's everything. Because of this +1, the asymptote was shifted up 1. Here's my function table. I plotted the 3 points. The b value shows exponential growth. Domain is all real numbers, and the range, all y values greater than 1. All right, our last one, y equals -2 times 1/2 to the power of x minus 3 plus 4. So this one has everything. And just drawing your attention to that front number is a negative, so we're going to have a reflection. And it's a reflection over the asymptote, which has been shifted up 4. So before even making an XY table, I know that there's an asymptote here. Now, don't draw this, but let's see, this means since the b value is 1/2, it's going to be exponential decay. So I'm just drawing a real quick sketch that I'm going to erase. So there it's decreasing, And now if you flip that across the x-axis, it's going to look something like this. All right, so I'm going to make an XY table with 1, 2, 3, and 4. So it's a lot to think about, but -2 times 1/2 to the power of 1 minus 3 plus 4. So do your exponent first, so that's -2. So -2 times 1/2 to the power of -2 plus 4, you should get -4. So write 1 down 4. Okay, if we plug in 2, -2 times 1/2 to the power of 2 minus 3 plus 4. 2 to the power of 2 minus 3 is -1. And then 1/2 to the power of -1 is 2 times -2 is -4 plus 4 is 0. So 2, 0. Okay, plugging in 3. This one's easy because I have 3 minus 3 in my exponent. So this is 0. 1/2 to the power of 0 is 1. Times -2 is -2 plus 4 is 2. And that's probably good, but here's one more. -2 times 1/2 to the power of 4 minus 3 plus 4. All right, so 4 minus 3 is 1. 1/2 to the power of 1 is 1/2. Half of -2 is -1. Plus 4 is 3. So over 4 up 3. So as you can kind of see, we'll follow the curve. All right, domain and range. The domain is still all real numbers because it's all x values. But range, it's now y is less than our asymptote, which is at +4. So y is less than 4. So there is your full lesson on graphing transformations of the exponential function. Good luck.